and do some notes, and then hopefully you'll have time to work on your maze and your new assignment. You have a checkpoint tomorrow regardless, so you got to get it together. Let's go over. I want to skip number 7 and go to number 8. Why do I want to skip number 7? Yes, ma'am. 4 gets the point. Leading coefficient of a 4. I'm going to save that one because it's a little bit harder. I'm going to go to number 8 because it's easier. I need to know 2 things: that add a -5 and multiply to positive 6. And 2 gets the point. -2 minus 3 is -5. -2 times -3 is positive 6. So she is 100% correct. Yay. Number 9 is my favorite. Why is it my favorite? Yes, different perfect squares. 4 gets another point. 4 don't answer this, so what should I put as my answer? $3K minus 7 and 3K plus 7. Make sure you're putting the opposite signs. Otherwise, -7 times positive 7 is -49. First period, try to make them both negative. That would not give you -49. That's perfect. Let's go back to number 7 and be brave. I like guess and check, so I've got some options with my guess and check. Got me some options. Let's see. Here's why I have options, because of that 4 in front. I could do 4 and 1, or I could do 2 and 2. So I got options there. I also have options on the end with the 49s. What times what is 49? 7 times 7, and then what else? Don't overthink your life. 49 times 1. It took first period like half the period to come up with that. It was ridiculous. But it was first period math, no offense to them. Yes, it's one of those. It's so obvious you don't even think about it. Okay, so should I guess 7s or should I guess 49 and 1? I heard 7s, I heard 49 and 1. What do you think? You've answered a lot of questions. 7s or 49 and 1? 7, she says. Okay, if we put a 7 here and we put a 7 here, do they need to be both positive, both negative, opposite signs? They have to both be negative because we want to get a positive 49. -7 times -7 is positive 49. And the reason they're negative is because we want that middle term to be negative, which is why Brady was raising his hand, because he already knew all this, which is why I'm going to give him a point, because I knew he knew all this. If we FOIL this out and check ourselves, we'll see if we're correct today. Maybe we'll be right first guess. Normally you're not, but maybe. 4p squared minus 28p minus 7p plus 49. Are we correct? Was that a good guess? Why? 2 and 5 get a point. Yes, when we combine those two like terms, we will get that -35, so this was the correct guess. Yay, good for us. Hot dog. You're going to answer 10, aren't you? Let me get someone to tell me. Oh, I bet you know this as well, so you can get multiple points for this. Number 10 is the difference of perfect cubes. You were supposed to memorize this. If I were you, so this is me getting on you for the last test. I do not have them all completely graded, so sorry, don't ask. On the last test, people did great on the back hard ones with synthetic and long division. People did great saying the degree and the number of zeros. Do you know where most people made their mistakes? The first couple dealing with rules of exponents, which came straight from the math workshops. So if I were you, I would be worried because the math workshop problems are pulling is where you're killing it. So if I were you, I'd put a star by number 10. I know what it is, and so Brady's determined to answer it. Let me finish my rant. He knows it's that too. I know you know. So I would put a star by number 10 because I'm promising you on the next test there is a difference of perfect cubes just like this. So you've got to recognize it and know the answer. Before you start answering stuff, do you know the acronym that we're supposed to remember? I heard it from 4 and 5. Did anyone else say it? 2. 2, 4, and 5. Get a point. It is soap. And we said the S was for same sign, opposite sign, and then always positive. And why do we need that acronym? That helps us determine the signs between our binomial, which is going to have 2 terms because it's binomial, and our trinomial, which has 3. Same sign will I have a negative, so same sign would be a negative. Opposite sign would be a positive, and then always positive. So we just have to figure out the numbers and variables to go in these gaps. And that is where Brady's coming in. Go ahead and take it away, Brady. Okay, as a reminder, yes, x raised to the third is x to the third. Duh. I'm pretty sure you would have figured out the x part. You're supposed to know your cubes, so 3 cubed is 27. X and 3, that part's pretty easy. You always square it, so x squared, 3 squared for the 2 on the end of the trinomial. You do 3 times x to get the middle. We practiced a bunch of these the other day in our first math workshop, so if you're wanting to study more of these, we have done tons more. You need to study them because there will be one on the next test. Okay, are there any questions about this one? We're going to save the rest of them for tomorrow. I love your cute handout from yesterday. Your cute handout from yesterday is useful, but we don't need it. We're not adding more to that directly today. We need your old notes from the last test. Your old notes. In your old notes, go to page 3 of your old notes and go to the back. Do you really think I'm going to take a maze that I see you coloring right next to me looking at someone else's key? Do you really think I'm that dumb? Because I'm not. I'm going to need you to get out your notes. It's the back of page 3. It looks like this. It says independent practice. I want to start there. Yes, dear. She already...
Can't come back until Monday.
Okay. Okay. She already emailed me like a book this morning. No offense to her, but a book at 7:30 is not exactly my way to start the day.
Let's just take one. Did she say like a lot in it?
I don't even know. I just was like, okay, do what you need to do. Hope you feel better about it. Okay, I want to start on this, but before we even go there, I need help with something very simple that we discussed yesterday, and I'm hoping you remember today, or else I might cry. We discussed that from now on you need to know the shape of a couple basic graphs. If it is a squared or quadratic, what should the graph look like? It's a parabola, so it's either, what letters of the alphabet? Or, okay, so the positive in front means it's a U, the negative in front means it's a, okay, 2 handled that for me, so we're going to give them the point. Great, yes, you're supposed to remember that. Let's skip the cubes for a second and go to the one to the 4th power, the quartic. Let's go to that one. Baby doll, if I have to talk to you again, it's not going to be nice. You might want to get on Earth with us now. I understand. I'm going to need you to put the maze away until it's maze time. Okay. Okay, to the 4th, it's supposed to be a W or an, okay, depending on the sign out front. Since it's a positive, it's a, and since it's a negative on the other one, it's an, okay. 2 and 5 get the point. And then we deal with the cubes. The cubes are supposed to look like what animal? Snakes. Snakes. Okay. And 1 gets the point. If it's a positive out front, we want to go up the wall. If it's a negative out front, we want to go down the wall. If you've forgotten the wall thing, let me explain. When we read, like when you're reading text messages like Naya is, when you read from left to right. In the same way when we read a graph, we read from left to right. So when I start on the left, because we read from left to right in life, when I start on the left, if I'm looking at this graph, it looks like my snake is going up the wall. And then when I read from left to right on this one, it looks like that snake's going down. So if it's a positive cube, the snake goes up. If it's a negative cube, the snake goes down. Why on the squared in the 4th How do they match? What were we talking about yesterday as to how they match? They are even. So their end behavior is both up, yes. Or their end behavior is both down. Perfect. 2 and 4 get a point. Perfect. Cubes and any other odds have opposite end behaviors. Notice how this one's down, this one's up, this one's up, this one's down. They do not match. Okay, if you understood that post-it and you helped me fill it in the way Abby Grace did, you got this. We're not going to make it any more complicated than that. We are going to add in the zero stuff we already knew in life. But seriously, if you got this, you've got the point of it all. Let's practice. We've got 3 problems we want to practice. It says, describe the end behavior. Determine whether it represents an odd or an even, and then state the number of zeros. Okay, so tell me about the end behavior. That does not tell you about the end behavior. Tell me about the end behavior. Both up. So that does mean that leading coefficient has to be positive. That's true. Don't need to use that pen anymore. Okay, tell me about the degree. Travis said it is a 4. He would guess, which is good. I just need to know even or odd, so clearly he understands it's even, since they're both going up. And then I need to know the number of zeros. 4. So it's at least a 4th one. He is correct on that. Okay, so this one's a little more complicated. I'll give out more points for it. Tell me about the end behavior on 36. Okay, the end behavior is opposite. Let's be specific. The left is up and the right is, okay. And then, so the answer to this one is clearly going to be, the degree is, well, but just tell me even odd. The degree is odd. And then that leading coefficient, is it positive or negative? Why is it negative? It's going down that wall. To begin with, it starts off going down the wall. And then how many zeros do we have? 1. 1 get a point and 5 get a point. 2 will understand. She's got herself a lot of points. Last but not least, 37. Tell me about that end behavior.
I can tell you about the zeros.
Okay, tell me about those zeros.
There's 1.
There is only 1. Yeah. Andrew, say what you were saying again.
The left is down and right is up.
You can have a point for that.
Hey, we didn't even need cake.
Okay, say your words again. Positive, he says, but then he said the degree was even. Something's wrong with this. What's wrong with this? Why? Thank you. 1 get another point. The degree is odd. The end behaviors are going opposite directions. Now the snake is climbing up the wall, so it is a positive leading coefficient, but since the ends are going opposite directions, the degree is odd. Are there any questions about 36, 35, 36, 37? Okay, that middle half, that's basically what it's going through, and you've already got it. The only thing I want to add is what Landon and I specifically were discussing the other day, and I had a blonde moment, so I can fix it now. We discussed multiplicity, and if a graph had a 0 somewhere, and we said that 0 is multiplicity 2, or any multiplicity that's even, it's going to end up having a hump at that spot, so meaning it's going to touch it and then go back up. We might call it a bounce. So if we have an even multiplicity, it's going to do that little bounce we discussed. Now, we were working a hard problem the other day that we should have skipped. where it had an odd multiplicity. So if, let's say, this is our 0 and the multiplicity is 3, it doesn't actually do anything cool. It just does like normal and just crosses through. So it's just normal. Or you can put crosses through. It doesn't get to have the fun bounce. The bounce only happens with even multiplicity. Nothing fun happens with odd multiplicity. How annoying. Poor odd multiplicity didn't get to do anything fun. Okay, and again, we did some of this on Friday and Monday. So this graphing stuff, besides the end behavior that was new yesterday, this graphing stuff should be no big deal. So let's look at 8, 9, and 10. We should be able to knock them out pretty easily. Okay, on 8, I need to know my zeros. And 2 gets the point. I've got zeros at -3, -4, and +2. There are like 3 people in the room who are putting the wrong sign for their zeros. We're doing the opposite sign. So you shouldn't have 3, 4, 2. I mean 3, 4, -2. You should have -3, -4, +2. So -3, -4, +2. That's where my zeros are. Okay. And that's great. But we still need that list of other stuff we've been making. What is the degree? How do you know it's a 3? -3, I did. Thank you, ma'am. -3, -4, +2. Thank you. Ignore that. That's wrong. Okay, the degree is 3 because that's understood to the 1, that's understood to the 1, that's understood to the 1, 1 + 1 + 1, that is 3. Tell me about that leading coefficient. It is 1. Is it positive or negative? It is a positive 1. Okay, so I'm not going to connect the dots yet. I'm just going to think things through. Again, now that I know the degree is 3, I know it's a snake. Since I know the leading coefficient is positive, I know it's a snake going up the wall. So I know when I connect the dots, it needs to end up looking like that. Okay, do any of my zeros have a weird multiplicity? Multiplicity other than 1? No. So when I connect the dots, I literally am just going to start at the bottom. It's got to cross through this. It's got to cross through that. It's got to come back up through that third one. But as long as DJ has a snake going through his 3 zeros, and as long as DJ's snake is going up the wall and has different end behaviors, he's gonna get all his points. So let me say all that again because one was zoned out for a second. As long as DJ has the fact that the ends are opposite because the degree is 3, he has it going, the snake going up the wall because that leading coefficient is a positive, and then he's hitting those 3 zeros, he's going to get all his points. Now, does DJ have to be my twin and connect the dots like that? No. Again, we're just making an educated guess. His could look a little different than mine. You know what I'm saying? Like his could look a little more stretched out or a little more shrunk. If we were really being picky, we would think it through. Like if there was a number out front, it really stretches me, like a 7, whereas a 1/7 would really make me fat if we were thinking it through. But again, since we're not even getting our graphing calculator, as long as his end behavior, zeros, and the general shape of the graph is correct, I'm going to give him all his points. Okay, number 9 is hard. Are there any questions about 8? Okay. -3 and 1. And then what else did you tell me? The degree is not 3. We can add today. We got this. It's 5. 3 plus 2 is 5. The degree is 5. And that's why this one is hard. So if I were you, I'd note that this one is hard. Now, I might ask you on the test to list this kind of thing. On the test, I'm not actually going to ask you, like, what should a degree 5 look like, as picky as I am. Again, we've learned the W's and the M's for 4. We've learned the snakes for 3, the U's and the N's for 2. We've not memorized the degree 5 graph. So we're going to make an educated guess, but there shouldn't be a degree 5 one on the test, because if you see 5 or higher, I swear to goodness, your teacher better give you your calculator, because otherwise they just mean. Okay, the leading coefficient is what? It's a positive 1. And then last but not least, we need to know the multiplicity. That matters on this one. We have multiplicities we need to deal with. Okay. Okay, so 2 and 3 at a point. Okay, so my zeros are at -3 and +1. Since my degree is 5 and my leading coefficient is a +1, I know that the end behavior is going to be opposite signs because the degree is 5. And since it's a +1, it's kind of a snake. I know it's going to start off like this. I know it's going to end like that. It might be more complicated than our normal snake. Or it might be just like our normal snake. I don't really know. Again, degree 5, I don't know that the way I know degree 3. But I do know since it is a 5, the ends have to be opposite. And I do know that since it's a positive leading coefficient, it does start up going up the wall. So while we're kind of guessing in the middle, I know what's going on the 2 ends. So for sure I know it's going to start down here like this. And for sure I know it's going to end up here like this. But in the middle, I'm just kind of making a good educated guess. I know it has to cross at -3. Since the multiplicity is a 3, it doesn't get to do anything cool. So it just crosses there. Nothing cool happens. But meanwhile at 1, since it has a multiplicity of 2, I know it gets to have a cool hump there. So I'm pretty confident with the green. I knew it had to have the cool hump because of the multiplicity of 2. I knew it had to have the ends going the opposite ways, the way they are, because that degree of 5 and the leading coefficient being a +1. But here in the middle is where I'm kind of making my guess. So maybe I just connect the dots. Like, or again, it might be something that in the middle here, maybe it just comes straight back down. I did not connect that well. Let me try again. It might just look like this in the middle. I don't know. So it could be that Sharpie thing. It could be that green thing. I don't know. We don't really know in the middle. How would we know in real life? We'd use our stinking graphing calculator. Again, for this test, as long as Jemiah has the opposite ends because the degree is 5, and she's got it crossing at the zeros, I'm not going to be mad at her. And I'm promising her there is no degree 5 she has to graph on the test. She might have to make this list, but she's not going to have to graph it because, again, we're just making an educated guess, and I don't like just guessing. I like knowing. On number 8, I'm pretty stinking confident, whereas number 9, like it's a little wishy there in the middle. Okay, 10's a whole lot better. What's the degree on 10?
3.
The degree isn't a 3. It's 4. 1, 1, 2, add together the 4. I'm with you. I wanted it to be degree 3 too. It's degree 4. And that leading coefficient is -2. So I already know I'm going to have what kind of a graph? What letter of the alphabet? It's going to be an M. The degree's 4, so I knew it was a W or an N. Since it's a negative leading coefficient, I know it's an N. Now for my zeros. Where are my zeros?
2, 1, and 3.
5, you get your point because you got the one in the -3. God bless the rest of you. She just had a moment. Everybody has moments. My gosh, we're not perfect. If you think people in first period didn't say 2 as well, you're wrong. They did. Again, we're just to figure out the zeros. We set it equal to 0, and so we'd end up getting 0. But would I have done the same thing on Monday? Oh, gosh, yeah. Thankfully, I've ate my Wheaties this morning, so I did get that one correct today. But what I always know, they're tricking us on that one. So make sure your zeros are correct. So 0, 1, and -3. Okay. That's not annoying at all. There's one last thing I need to think about. What is that before I go crazy graphing? That multiplicity. 1 has a multiplicity of 2. So I know at 1, and then again, I'm smart. You and I both know I'm going to make an M, right? Like my goal is for this to look something like an M. Now it might be an ugly M, but still it's going to be an M. If you had to say what letter of the alphabet that graph is, you'd say M. Okay, so at 1, I know there has to be the hump. And I know the hump has to be down because, again, we're making M's. We're not making W's. We're making M's. So my graph might look like this. But again, the reason I'm saying it might look like that is I know that right hump of the M has to happen at the 2. Because, or it has to happen at the 0 that's a 1 because that 0 has a multiplicity of 2. I'm positive that hump has to happen there because of that multiplicity of 2. Let me say that one last time because that's the hard part. Like, you're cool with the fact that you connect the dots and you make an M. But specifically with this M, the hump has to happen there. All because that specific 0 has a multiplicity of 2. So it designated where that hump had to happen. I don't really know where this other hump had to happen. It could have happened higher in the air, lower in the air, etc. But that hump had to happen at 1. Had to. Because of that multiplicity of 2. Okay. Now, if you graph this, my graph that I've guessed here is actually wrong. Because someone in first period, they cheated, doggone it. They used their graphing calculator and they found out that it was actually a much more stretched out first time. Why do you think that is? And you're not going to get counted off on the test if you have exactly what I had to begin with. But why do you think it should have been a more stretched out hump? Because of the 2. The 2 should have stretched it out more. Yes, dear. You know, people want to know eventually where that max is occurring, where that top point is. And so, technically, wouldn't that really change that top point? Now, I have not asked you about that max yet, so I don't care at the moment. But eventually in life, like when we get to pre-cal, would they care where that max is? Yeah. On the ACT, Lord knows they're never going to take that graphing calculator away from you. Now, will life be a little faster since you know a 4 is supposed to look like an M? Yeah. But you'll always graph it on that graphing calculator just in case you're having a moment, because we're not having moments on the ACT. Okay, I have 3 more I'm going to do, and they're a little harder. They're on the next page. Why are they harder? Well, I did say they're harder, but you look at them. Why are they harder? Thank you, ma'am. 4 gets the point. Do we know the zeros? No. We have to figure out the zeros. They're in standard form, not factored form. We have to figure out the zeros. I'm going to skip number 11. Why am I skipping 11? Because that degree is 5. 2 gets another point. That degree is 5, and I'm telling you I'm not putting any 5s that you have to graph on the test. I'm not saying you won't have to answer the questions, but literally Andrew needs to, him and 2 3s and 4s are all I really need in life until I allow him to have that graph calculator back. Once he gets his graphing calculator back, my gosh, he can do anything. But for now, while he has to just use his brain, I'll take 5 off. Okay, as for 2 and 3, 12 and 13, sorry. I still need to know some things. And some things I already know. What is the degree? What is the leading coefficient? 3, and the leading coefficient is positive 1. Thank you. So tell me about that graph. It's a what? Up a what? And then tell me more. Yeah, it's a snake up the wall. I don't know if your group's already at 5. Surely they are. Yeah, okay. So I'm going to have to figure out the zeros in a second. But at the end of the day, my graph's going to look something like that. Because my degree is 3 and my leading coefficient is positive 1. I know it's going to be a snake up the wall. Okay, so now let's figure out more specifics about those zeros. We need to factor this and figure out our zeros. Is there a GCF? What is it? If we take out an x, we're left with x squared plus 7x plus 10. Can you help me factor further? Yes, it is. Thank you, too. She got it out first. Sorry for her. And 0. And you get a point for that, ma'am. So since we factored it, our zeros are at 0, -2, and we're going to put -5 down here on the end. But again, you and I know it's a snake. Do any of these zeros have a multiplicity that we need to be concerned about? Anyone got a multiplicity of 2? No. This one's a 1, this one's a 1, this one's a 1. We're not worried about anything. So literally when I connect the dots, all I'm thinking about is my snake climbing up the wall. So snake, go up the wall. Now your snake might have gone a little higher. Maybe your snake went a little lower right in here. But as long as your snake has the same end behavior, he's going up the wall and he's crossing through those 3 points, you're going to get all your points in life. But again, just because I knew the degree and the leading coefficient, I knew it was going to look something like that. Us figuring out exactly where those zeros occurred helped, but I already knew it was going to look something like that. Are there any questions about 12? Okay, let's handle 13 and knock him out too. The degree is
4.
And the leading coefficient?
Positive 1.
5 gets the point. Because of that, what do I already know about my graph? Is it an M? It's a W. It's a W. Degree 4. Positive leading coefficient, it's a W. It would be a U if it was degree 2. It would be an M if the leading coefficient was negative. But since it's a positive leading coefficient, degree 4, it's a W. Now, my W, again, might end up being a really ugly one. I cannot promise it's a pretty W, but it's a W. Okay, how can we figure out these zeros? Okay, if we take out that x squared, we would be left with x squared plus 8x plus 16. So, okay, 4, you get the point. I really ought to write one more line before I write out my zeros. Any thoughts as to why? And why would I do that? Yes, and 2, you get 2 points. Okay, so you're like, Miss Compton, why was this line necessary? And Jessica nailed it. The reason I wrote that line the way I did is, doesn't that help us realize that that 0 of -4 has a multiplicity of 2? So yes, I have a 0 at 0 and a 0 at -4, but Jessica's helped point out the fact that both of them have a multiplicity of 2. Because they both have a 2, they both have a multiplicity of 2. So I'm going to 0, I'm going to -4, but even more specific than that, sadly, this graph is the most specific of all the ones we've done. Because of that multiplicity of 2, I know it's a W, yes, but because of that multiplicity of 2, I know exactly where those humps on the W have to happen. So yeah, it's a W, but I've got to put those humps exactly on my zeros because of that multiplicity of 2. This one has a multiplicity of 2, so it has to have a bounce. This one has a multiplicity of 2, so it has to have a bounce. So maybe mine and Jessica look a little different in the middle, but regardless, the humps of the W have to go at those zeros because of that multiplicity of 2. Okay, so Jessica might have done this. Maybe hers look like that. Maybe yours looks a little different. Hopefully not as ugly on the end right there. Woo. The hump. Woo. But regardless, Jessica and I matched because we thought since the multiplicity of 2, we have the humps there, and both our ends are going up. Now, maybe yours is a little different in the middle. Again, maybe you went a little higher with your middle hump of that W. But regardless, we made a W, we hit the zeros, and specifically the humps happened at those zeros because of that multiplicity. Are there any questions about that? Now, clearly to goodness, we need to practice this. That's obvious. Let's go to the next page. It says page 12. Tomorrow, all we're going to do, work on our maze, take a checkpoint, and work on this page. Any that are degree 5 or higher, you do not have to do unless you want bonus. So the other day, you and I were being super brave, and we were trying this one. It was degree 3, 4, 5, 6, 7, 8. Do you have to do degree 8? Heck no. Anything 5 or higher, you don't have to do. It will be bonus. So, like, you don't have to do number 4, but you do have to do number 5. So if the degree is 5 or higher, you don't have to do it unless you're wanting some bonus. So otherwise, you need to make a good faith effort. And yes, on some of them, like number 6, you're going to have to factor so you can figure out where those zeros are. But again, Eric should be smart enough now that on number 6, since it's a positive and it's a 4, he should know at the end of the day it's a W. Can you use a calculator on 5 or higher? Yes. But you know that if I see you using the calculator, I'm assuming you're cheating. So would I rather you just make a good old educated guess? Yes. Okay, are there any questions about this? Life got deep today. Okay, it should be pretty easy and straightforward unless you tuned out